Hi, Blaine Mercereau here from TSE Data Services. I'm here today at FreshPal Farms to talk about new technology that we're bringing to the agriculture industry. FreshPal is operating a greenhouse in southern Alberta, just outside Olds, in an environment that gets kind of cold sometimes. Last January, it was down to about 40 degrees below zero, and FreshPal was able to continue to grow vegetables in their greenhouses even though it was quite cold out. We'd like to talk to you about how this was able to happen and the technologies that TSE and FreshPal are bringing together to help out with the greenhouse industry. And here we are inside FreshPal's greenhouse. As you can see, it's kind of warm in here. I've got my coat off and it's quite warm for growing tomatoes. FreshPal is able to grow these fine tomatoes all the way through the winter. We've been able to keep the place warm inside here through a couple of different kinds of technologies. Some technology that's come from China, as well as some technology that we brought forward from TSE Data Services. As you can see, the tomatoes, here we are in January, and the tomatoes are quite nice, growing on the vines, and there's about 90 meters of greenhouse here, all filled with tomatoes. The tomatoes are quite good. They're juicy and good. So here we are, still in the greenhouse for FreshPal Farms. TSE Data Services has partnered with FreshPal to bring some of the technology forward that TSE is working with to help out the greenhouse industry. What we have here is TSE Data's equipment installed in one end of the greenhouse. This equipment is a series of computers and cooling systems to help TSE with their business. TSE operates a hosting business where we provide an environment for computer operators to install their equipment and run their operations. This particular operation is used for Bitcoin mining, and the equipment that is being used is water cooled. So what we've done is we've taken the water that's coming off our computers for cooling and flowing it through a whole series of heat exchangers in the greenhouse to keep the greenhouse warm. Let's just take a look at the computers now. So here we have TSE's equipment, which is a partnership with HeatCore Technologies and TSE Data Services. We have a series of 8 computers here running for the Bitcoin mining industry. Each of these computers is cooled by water. That water is brought down here and exchanged. The heat in that water is exchanged with heat that's being circulated in the greenhouse. Let's take a look at the pumping system. So the water is coming from the HeatCore equipment for TSE. Is being pumped through a series of pumps held into a reservoir here that we use to mix the water. And from here we pump water through various pumps. We've installed radiators along the top of the greenhouse to distribute the hot water throughout the top of the greenhouse and keep it warm. We've installed a series of pipes to supply these radiators with hot water, and more pipes to return the hot water back to the system. And here we are again outside the greenhouse now to show you an important part of our process. The computers that we're using to heat all that water inside the greenhouse use an awful lot of power. About 90% of the power that's used is lost in wave heat, and that's what we capture to heat the greenhouse. We get the power to run that computer by a gas-fired genset outside. Here we're using a temporary genset that we rented until we have our own equipment installed, probably in March. We'll be using Stirling engines, which are very good at taking the waste heat from the engine and providing that to us to work with inside. This particular engine is about a 25% efficiency engine when it's converting gas to power. Our Stirling engine, when it gets on board itself, will probably be about 40% efficient. That Stirling engine, once we capture the waste heat off it and use that waste heat to heat yet another greenhouse, then the overall efficiency between the waste heat that we're capturing off the genset and the waste heat that we're capturing off the computers will make that system, that total system, about 75% efficient in capturing the energy from the natural gas.